competition, having a studio project, and then another project I'm working on too as well. So I have 3 projects in 1 semester, so it's a very time-consuming thing. So it drains all my time, and if I do have time, I would rather sleep. And the reason why I'm not sleeping right now, even though I am a little under the weather, I want to just pump out a video for you guys and I was working on something and I wanted to take a break. So I thought this is a good way to take a break, kill 2 birds with 1 stone. I create something on Grasshopper to show you guys that I thought was interesting, and you guys get to experience that. So I'm going to work in top view for majority of this. There are times where I'm going to go switch to perspective view to see the kind of surface effect that I'll create. But other than that, I'm going to create this now. So it depends how you want to start this. You can do it 2 ways. You can draw a surface on Rhino like this, so it's plane, and then after you do plane, you just reference it. Set 1 plane. Oops, not plane. Surface. Set 1 surface, and then you do that. Or you could do plane in Grasshopper and just kind of define some dimensions. So let's just say it's a square for right now. And you can actually start to define the dimension of this square. So I'm going to keep it at probably 30 by 30. I'm going to go this route just because it's solely a Grasshopper script. And if I was creating this aside for a project, I would reference it because it's easier and it will be the exact dimension instead of me kind of playing around with number sliders and figuring out which one sort of fits. So there we go. So what I would do now is divide the surface. So before I go any further, I just thought about this. I'm going to talk about the overview and the quote-unquote plan of attack I have for this, or like the kind of logical thinking I'm having while doing this, because right now I'm just making the script, which doesn't really help you out. So I want to go over my logical thinking on this. So the logical thing I'm having with this is if I look at this, it's just a surface right now. So I'm thinking of this as 1 surface, and it has this ripple effect. So what do I know in my head that does that? And I know an attractor point can do that. I've done it with 1 attractor point, and I've done it with multiple, but to get this effect, it's a little different. So I'm thinking attractor point with curve, because literally you can see, even in this, there is a curvature. Like someone created a curve in CAD software. It doesn't necessarily be Grasshopper. It could be any other Dynamo, some other one. A curve to base it along of. So I know that I'll need a curve. I know that it's a surface manipulation technique, and it's a contouring effect, as you can see these little panelizations. So let's create that. So let's get on to it. Now that's the logical thinking. So I've created my plane and I have my surface. Now once I do that, I'm going to do I want a large point count, because it looks like from here there is to get this type of articulation very clear, you have to have a large point count. So I'm going to do that, and I'm going to have a pretty fairly good point count. So let's say 21 for right now. I can always increase it, so there's no problem. So now we're going to get to the actual attractor point. We're going to move it, and then we're going to have an attractor point base. So we're going to start with an amplitude. Once we get to the amplitude, plug this in here, and then this vector goes into the normals. Now I could say Z and plug this in here instead, but this is already given to me based off the points. I'm just going to utilize what I already have. So I can delete that. And now I always plugged in the geometry last, just because I like to plug in everything and then plug in that last part. Then we're going to do a remap numbers. We're going to plug in this mapped to amplitude. Then we're going to do a bounds. And then we're going to finally do a closest, not finally, we're going to do a closest point. Plug that in distance into here and here. And then in order to get the kind of values that we want, we're going to do a construct domain. And this will give us our values that we need. And I'm actually going to move all this a little bit over here. And now we're going to do, we're going to set a point, but we're not going to just do point and then set it. We're not going to do that. We're going to do it differently this time. So first I'm going to plug this in here because these are the base points that I'm moving. Instead of doing point like we just did, I'm actually going to go back in the Rhino and create my curve. So I'm going to insert a curve. Like this. Let's say I want my curve to look something like that. That's a really weird curve actually. So I'm going to reference that curve in Rhino. Set one curve. Nice. And then we're actually going to do a divide curve. And then we're going to set this to 12. So now we have 12 points on that curve. And we're actually going to put these points into the cloud right here. And then the geometry into points. So now let's see what happens. So right now, it is moving those points, but I don't know what's going on right now. So I'm going to actually, because it's hard to tell what it's doing with points, so what I like to do is I'm going to actually hide the divide surface and points, and I'm actually going to do a surface from points. So I know my count here is 21, and I think, I always forget this, but the U count is +1. Let me try this. I think it's +1 of the U count here. Because it's asking for the U count of points, so you can use your divide surface as a reference. And it's not. Okay, well, what was it, 20? Is it 21? Okay. Let me try plugging this in and messing around with the slider. Oh yeah, okay, never mind, I remember. I had this trouble too. So, how this works, I'm going to explain it before, because I know the solution, but I don't want to just do it, I want to explain it. So let's look at the panel. Let's say we plug this in. We have an error, and it says surface cannot be fit, and you're like, well, that doesn't help me out, right? I mean, it doesn't, so let's scroll down here and look at our list. So our script is, what's it called? It's grafted, or not grafted, it's partitioned by 0 to 21, which is 22. So this should be right, correct? Because it's 0 through 21. Technically 0 is 1, so 22. So 21 plus 1 is 22. So we should have it correct. It's the same number, but the problem is they are partitioned. So when it's partitioned, it doesn't understand it. When you use a surface from points, so scribble. So when you use a surface from points, you must flatten. You flatten it because it will now read it as one list instead of creating instead of, because, okay, let's think about it this way. Instead of using one series of points. Now that may not make any sense to you, and I'm going to explain why it makes sense to me. Now, let's think about it this way. We have 0 through 21, right? Which, let's say it's these. We don't know if it's either this way or this way. I haven't really looked at the list enough, and it's probably, I don't know, it's either this way or this way. It's either vertical or horizontal, but it doesn't matter. So let's say, let's draw in Rhino actually. So let's say we have these points right here. That looks kind of funky. Sorry. When it looks weird, I have to fix it. So let's say we have these set of points. The problem is right now they're all partitioned like this. So when it tries to create a surface from points, it's trying to create a surface from these set of partitioned points. Can you create a surface with a line of points? No, you cannot. You can only create a polyline. That's like the only thing you can do with a series of straight points. So if I do polyline here, I can easily get one. So you can see, okay, so it's reading vertically. Okay, well, let me flip this around. So they are reading vertically. Okay. But see, if I had, now let's look at this. So if I had that line right there, you can't make a surface with one line of points. It's impossible. You can't do that. It's not. It's physically not possible if you create a surface with this one point. It'll just be a line. And as you can see, this polyline is proving me correct. It is literally making this one line here. And it's not. If it was a polyline, will read from start to finish of the list. But if it's partition, it'll read from start to finish and start again, like this. But let's say if we flatten it, it's going to start to, let's say, follow this line, and then make another line, let's say this way, and then keep going, make another line this way, and it will actually start to continue, and it'll be one continuous line. If we look over here right now, it says 22 local defined values. Now, if we flatten this, we're going to get one locally defined value. And as you can see, it's like creating that. So now we have to flatten it so they all read as one under one kind of partition. So let's do that. Flatten tree. Let's flatten this right here and throw this in here. So now we got our surface. All right, cool. So I hope that made sense. I wanted to kind of show you guys that, and I think that makes sense to me. So flatten tree. So now we have our kind of manipulation of points right here. So what we want to do is we actually want the domain start to be this, because the domain start is whatever is closest to the point. So I want this to be 1, they'll both be 1. I want this to be 0. Let's say if we flip it, let's see what this does. So right now it's flattening it like this. So you can see it's actually starting to create that geometry. Now, there's, what's it called? Now, as you can see, it's kind of subtly creating that. Let's say I want it more sharp. As you can see right now, the surface is very underwhelming. Like, it's just, if I just, let me just turn this up to, let's say 20. As you can see, it's raising it up, but it's raising up the whole thing. And it is following that curve, but it's also lifting everything up. Let's say I only want everything to be flat, but where the curves are the proximity is too far, as you can see. The proximity is from, like, let's say this point to all the way here. And the proximity is super large for this. So, you see this is the only point that's, like, touching 0 still, which is not what I want. So I don't want this type of weird surface. I want a little bit more control over the surface. That's a better word for it. A little more control. So I'm going to actually throw this down here. And I'm actually going to group this right here, just so it's out of the way. And we're going to actually use Graph Mapper for this. And I'm going to lower this down to 3. Now, let's see. What I'm going to do now, let's do a graph. Now, this takes a little bit of experimentation, whatever kind of articulation you want. But I know that if you want just a bump in it, kind of like how this is, you'd use a conic graph, I think. I think it's conic, yep. So I'm going to change these values to, so the Graph Mapper for me is still a little confusing, so I'm going to try to explain it as best I can. But basically, Graph Mapper is based off, sorry, I have something on my skin. That was kind of weird. Graph Mapper is basically saying, basically saying I want to use these as my kind of reference math, how it calculates the kind of surface manipulation. So when it says 0, 1 and 0, 1, its proximity is literally 0, 1. So the way to kind of hone in on it is to change these values. These almost change the quote-unquote proximity of the curves. So I'm going to do 0, 5 and plug these in. And you would literally just replace it with these two. So as you can see, it's better. As you see, it's flat. And now it's going. But there's still, if I turn it to high quality, which high quality is awesome. So go high quality. There's still a little ripple bump. So we're going to try to fix that by just messing with the conic graph. And let's see. So we're getting these weird, these are in the way. We're going to try to fix this. We're going to try to make these as round as possible. As you see, 5 has a huge effect. So let's go back down to like 3. Okay, so maybe conic was not it, because I don't want these bumps. So let's try a different graph. Let's try the Bezier. I think this could be it. I don't remember. I don't remember exactly which one I used. So something like that. Let's try playing around with this. So Graph Mapper is basically here to give you a more articulate surface, a way of kind of understanding how you want your curve to look. So this is a way to actually manipulate it with some control. But it keeps giving me these bumps, and I really don't want that. So I'm going to change the number. Maybe higher could be working. There's a lot of trial and error with this, so I'm going to do something a lot larger, 15. Okay, let's change it back. If I keep it at 1, what would happen? Okay, so it reads it a lot more severely. Okay, let's change, first of all, let's change this height to 2. And let's try conic or some other graphs. I'm just trying things, like that's the way I think you should do it. Don't be afraid just to try things. It's a little daunting, but this is a process that is required. And that looks pretty good. I want a little better, but ironically, I think that's the best I'm gonna get, but I want to understand what it looks like. So I'm actually just gonna bake it real quick to see what it looks like, because I can't tell from my preview. It's transparent, so. And now, that looks pretty good. So let's try now to lower these values. And if you want a little bit more control over this, I would suggest you can actually start to, what's it called? Go to a rational and actually start to play around with these values. So that one's peaking high. So what I would do now, so I know these points, this point is right here. So I do points on. I'm actually going to I'm going to move this up. So it creates that. As you can see, you can even see like the impact radius it's having. I'm trying to minimize that kind of look of the impact radius just by minimizing how it looks. Okay. Now, I think maybe, because right now they're reading on a list, so that's why it's reading like each one. So I'm going to try, what happens if I flatten it? Oh, got some freak out geometry. Oh, no, I didn't get anything yet. Flatten. So now they're reading the same. And now, well, I can turn off this polyline. I don't know why this is on. This polyline. Why is it? Are these the surfaces? Oh, those are the surfaces. Okay, well, I couldn't tell. Okay, this is giving me 10,000 values. That's probably not good. I'm going to unflatten, or not reverse. Oops. I'm going to unflatten this and actually give unflatten these. So right now I'm just experimenting and tinkering around to see if I can get a better result from this. I'm getting my 10,000. So right now it's 484 and it's translating to 10,000. So something is creating it to make it 10,000. So let's look. It could be, we can trail it down looking at these, so we know that this is still 44, this is still 44, and this turns 10,000. So I'm going to try flattening probably this one. Okay. So it still has that little bump. So, it's getting better. Not because I flattened it, but let me see. I can plug this. No, I can just keep flat. I can keep that there. And I'm trying to think if I can make this curve better. I always try to see if I can do it better. Let's try either a Gaussian or a parabola. So right now it's reading like that, and I'm going to try to soften it up, make it 0. Let me switch these numbers. Alright, so those ripples are still there. Let's see if I can kind of get rid of them. So if I fatten it, it gets rid of some of them. Let's create divots. Does make it independent. As you see, it's very point dependent. So I think I know what the issue is. I don't have enough division. As you can see, the more divisions I add, the more less rounded it seems, right? Because I just add a crap ton of points. So what I'm thinking is, what happens if I flatten? Ah, there we go. See? Just didn't have enough points. It's almost like tricking it. Bubble. So let's see if I can get rid of that little ripple here. I'm a bit of a perfectionist when it comes to this stuff, so I try to. I don't want to give you guys crap stuff, so I'm going to try. So, alright, that looks pretty good. I'm pretty happy with that. I don't know about you guys, but I wanted that kind of articulate area. Let's see what that looks like. I can't really see it too well, so I'm going to try baking it. Alright, and that looks pretty good as the surface. Now, that looks pretty good. Happy with that. And now what I'm going to do is save it. Because I haven't saved it in a while. So, Studio. Let's go to our folder. Architecture, and I'm going to call it. What's this precedence name? It's called. I have no idea. The surface generation, contour, surface planes. Final rendering views. Okay, they're just showing us. Oh, so they did use grasshopper. So they do have the grasshopper code here. Wow. Okay, that's. I don't know if they did. I don't think they did it the same way I did it, but I mean, there's multiple ways to do everything. Their one way is how they did it. There's a million different ways to do it, and I think the way I did it has a little bit more control. Just glancing at the script, it looks like they just did a project. Yeah, I don't like that. That's just personal decision. I don't know what this is called. Aim project. I have no idea what this is called. I'm just gonna call it not this building. I'm gonna call it a. I want to call it surface manipulation with curves. Oh, I can't put a slash. I forgot. Whew. And that's how you do it. Alright, and I'm going to continue this right now by making the contouring, since I think that's important. So I want to save the Rhino file as well. So I want to click this and delete the .gh. Okay, cool. Alright, I don't know if you guys have Rhino 6. If you don't, I will save as a Rhino 5 file as well, so no worries. So now that we have this, we're going to actually start to contour it. To contour something, you need it to be, what's it called? It needs to be solid. So what we're going to do is extrude it. We're going to extrude it just very slightly in the Z direction. And we're going to go, let's say 5 inches. Let's see what that looks like. That is very huge. Holy cow. That's not what I want. I want it to be kind of sliced. We can actually do some rational stuff. And move it up through here. And now we have our little bump. Now it's like kind of a solid, which is good. So now what we're going to do is we're going to do a contour, create a set of B-rep or mesh contours, shape, direction, I want it in the X direction. Oh, I meant this. And then units to be, let's say, every 2 inches. I don't know how big this is, so we can always. So it's every 2 inches. So let's lower that to every 1 inch. There should be double. And let's turn on rational, put 2. And to actually play with the amount. So 0.63. Alright, so now that we have that, that looks pretty articulate. We can always change that. So what I'm going to do now is extrude those curves in the X direction as well. And you want to make sure that your distance, your extrusion distance, is always lower than this number. So I'm just going to make it an eighth of an inch. Now it's hard to see, so I'm going to have to turn off those, and let's look at it. So that's sort of the panelization that I'm looking for. Let's see if the X direction was correct. Contour, extrude, got to cap it to make it solid. Silly. Oops, forgot to do that. So let's see if it makes it solid, and it does. Alright, sweet. So now we have our contoured surface. So let's bake this actually and see what it looks like. Kind of excited. It looks pretty good. So now that we have our surface kind of manipulated, we can see the effect that it has on it. So if my building had, well, that does not tell me anything. So my building, why is it? I'm going to put it in rendered because I can't see it. It's all kind of weird. Maybe I did too many. Maybe too many is definitely an understatement. Let's try doing a little bit less. Let's try doing like every and we can make these a little bigger. Yeah, alright, cool. Bake. Yes, please. Perspective. Alright, that looks readable. That makes sense. I'm going to now look at this. So now, it's a little, oh, because I'm moving it around a lot. So, let's say that's my surface. And now if we look at it, we probably want a little bit less, but the principle's still there. Where let's say if our building had this kind of weird circulation going on, like some staircase condition, and then we walk up to the second floor, you can actually start to map that using that curve. So architecturally speaking, this is very handy in terms of circulation, path, plane, things like that. It's very handy. So sun shading, it's very good for it. So now that we have this, now let's say our surface was weird looking, if we wanted this kind of weird manipulation of the surface, in order to create these kind of contours that go along with it, we would have to use a perpendicular frame. And I can do another tutorial on that if you guys want that, but right now I'm sticking with this. And I need to get back to work. So, this video is a lot longer than I thought it would be. It's like 30 minutes, yeah. That's not as long as I thought. Okay. Well, anyways, that's pretty much it. I am going to put this back on shaded first. I'm going to save this. So that's pretty much it, guys. So that concludes this tutorial. Hope you guys enjoyed it. Hope you guys understood. Hope you guys learned something. That's always important. And yeah, guys. Thank you guys for watching. Hope you guys have a great day. And let me save this. And I'll see you later. Bye.